Have you ever wished you could ask your data a question in a plain English and he gives you a spot on answer, like chatting with a colleague? Or imagine asking your data what is our top selling product this year. So he will give you a spot on answer along with the last year financial report. Sounds like a game changing, no? So hey, I'm Gaurav, a software engineer at GeekyAnts. So I'll make this whole thing happen in this tech talk. So stick with me throughout the tech talk. We will see this, how we can do this using Retrieval Augmented Generation with Snowflake Cortex. So let's start with understanding what RAG, or I can say Retrieval Augmented Generation is. Let's start with a simple example. Suppose we know a kid who loves exploring things, or I can say who loves reading and chatting the things. So if I ever ask about some question, he will give me a spot on answer. If the kid doesn't know the answer, he will simply try to give the answer that is not correct, or simply says, I don't know. That's traditional LLM, I can say. Now, suppose the same situation, but with a different scenario. Now, the kid has a library pass and a librarian who knows which topic, or I can say which book are present where. So now, if I ask a question to that kid and he doesn't know, so he will simply go to the library, ask the librarian about that particular book, and the librarian get the book, give to him. He will simply read the whole thing and give me a spot on answer. Congrats. That's what RAG is. It's basically a simple thing. It's basically a two-step process. First, finding the relevant data, just like the librarian did. And second, after finding the data, generate the precise answer. That's what the child gives. So congrats. You know what RAG is. So let's also understand by a simple picture. Like a user will send a query. Like I have asked that boy a question and the boy doesn't know the answer. So he will simply go to the library, find the relevant text with the help of a librarian, and after the whole thing, pass that data along with the query to some LLM, or in our case, it's the child brain. So he will simply generate the response. We can also see how RAG works with a simple flow. With a simple example, like if I am asking what's our vacation policy, and every company has its own vacation policy. So extended LLM don't know about everyone's vacation policy. So it will simply get the data from the handbook section, generate the response, basically find out the best relevant data based on my question, and generate the answer with the help of that data. So now we see why RAG matters the most. Like we are talking about RAG. So why it's matter? The first thing which makes it a lot better is accuracy. As we know, a standard LLM sometimes, or even I can say in the starting portion, it hallucinate. Like if you don't know, but he will give you a specific answer that is not correct. So here, RAG plays an important role. Like he knows about the data from which I am asking the question. So it prefer accuracy over hallucination. After that, it gives you a tailored answer. Like everybody has their own different set of question and data. So based on that, it will give you a specific context. And also, it will also provide a security. Like if you have a data of your own and you don't want to publish it or give it a public access, so it plays a significant role in that. So after that, what are the real world application in RAG? Like to be honest, like for the last 6 months is the most trending topic, I can say. In everything, they are like RAG. Basically, these are some simple things I can say. So like customer support, employees, resources, like the HR policies and all, the data analysis part. So we can make a chatbot or, for in any domain particular to that data. So here the excited part. We can do all of this with under a single hood, that is Snowflake. So let's go to the Snowflake. So first of all, like if you are working in ML background, so you know how data plays a significant role. Like if you have a data of your own, that means you are rich. Like you can do whatever you want to do with that data. So using the traditional LLM or the current traditional services, you need to put that data in some other services and use some other services to do the analysis on that data. Like there are two different services basically. So what Snowflake Cortex did, it will give you a whole room. I can say the library and the librarian whole are under your home, I can say, which simply says like you don't need to go anywhere else. I will save your data, I will do analysis on your data, I will do everything in one single thing, like in a one single, I can say, building. So that's why Snowflake Cortex plays a magnificent role. So it's basically a AI toolset that is building directly into the Snowflake platform. The second thing which make a Snowflake Cortex different from others, like it has a property known as Cortex Search, which will simply provide you a I can say in the form of librarian. I can say you have a librarian with some more intelligence, like for retrieving the product, or I can say I will give the topic to the librarian and he will give me the perfect answer, or can say perfect relevant book. So if I say I have a simple librarian who knows not much things, and I can say I have a librarian who knows everything about that library, so I will surely choose the librarian which knows everything. Now that was Cortex Search do. In the background, it uses a different technique, that is a hybrid retrieve technique, to find the relevant text. So that makes it different. And the best part about Cortex, why we choose Cortex, the first thing is it's super secure because your data is in the safe place. I can say you don't need any other tool or service to store your data somewhere else. The second thing is simple implementation. That for me, it's like game changing. Like if you know SQL or not a much, I can say Python, that I can say that's okay. Like if you know SQL and a simple Python, you can do whole data scientist thing. Like it provide all the things that can be happen in a complex coding only done by with the help of SQL itself. So I can say it's a game changing. Like you don't need any complex coding to be a data scientist under Snowflake Cortex, I can say. And yeah, it's handle the massive data set. It's quite obvious because you are using Snowflake, magnificent beast in its own domain, so it's cool. So now we have a lot of theory, like what is RAG, why we use Snowflake Cortex, how it's good and all. So let's start building and see how it works. So this is my Snowflake account. Whenever you log in, you go to this homepage. So for starting, we will go to this plus section, and here there is a notebook section. So if we simply put on the new notebook, it will ask what is the name of a notebook, what are the database you need to choose. So let's say I'll choose a RAG database. It's simply choose public. What are the warehouse in which we are storing our data, and a notebook warehouse. We don't need to think of it, and simply create it. So it's basically creating a setup for us. Okay, so I'll show you my notebook, which I've already done it, and explain how I have done it. That will be a easy part for you to understand. So it's a simple code that whenever we create a notebook, it will give you can see. So there are few things I need to explain to you. Like one of the thing is, it will provide us the option, like are we trying to run it in Python, SQL, or it's just a markdown language. First thing. Second thing, there is a package option. So in this package option, if we need any package, like I need Snowflake ML Python, so I'll simply just click it and save it. That's it. So there is a package involving this. That's it. And yeah, we have created this whole, a file in which we have used a database and a warehouse and all. We can also done by using the coding portion. I'll show you in this slide. So here we are basically simply creating database, name RAG database. Okay. And after that, we are making a warehouse, name RAG warehouse, with some properties. I'll explain these properties very short term. Like a warehouse size, like according to your data, you need to choose it's a small, medium, or large. The second thing is auto suspend. Like if you are not using your data, if you are not running for a 2 minute, it will simply close the working so that it will not cost you extra, I can say. Whenever you are start resuming code itself, it will auto resume, and in the initial it is suspended. So we have simply created the database and a warehouse. After that, in that warehouse, we are creating a stage. Yeah, I'll show you just by simply how we can do this. Like, this is the data and this is the add data. So in the add data, we are loading file into the stage, and you can simply browse it. Like if I am trying to say this, so you can simply database, you need to select the database, in that public specific the path. Okay, sorry. Yeah, we need to select the stage also and simply upload it. That's it. And you have seen in the right section, it's uploading. It is as simple as it. So we'll back to our portion. Just a sec. Like, yeah, one file successfully uploaded to bike details. So from that stage area, we will now, for doing a RAG, I can say, we will need, like, we have a lot of data in different forms. So our first task is to get that data. In simple terms, we can say it parsing. After the parsing portion, we will simply chunk into different forms. And after the chunking, we will convert this into embeddings. I am supposing you guys knows about these basic things. So yeah, we have created a stage named bike details. That's a simple. Yeah, we have the see, we have used encryption is equal to Snowflake SSE. So what does it mean? Like if I'm seeing the data which I have uploaded it, it's in the MD5. So it's totally safe because we have chosen the encryption mode. So we have the data in our stage, and for that data, we need to parse that data to use it. So for parsing, I'm simply using the SQL function. You are seeing, like, I'm creating a table named parse bike detail, and I am using there are two different inbuilt function for parsing the data. I'm using an inbuilt function like snowflake.cortex.parse document. It will simply parse the document for me. It have two modes. One is the layout mode and other was the OCR mode. So OCR is like quite easy, I can say, or I can say it's not that much of gives accuracy. So I have chosen layout mode and simply store it into parse details. So after that, we have created a table with this answer. Like we have chosen the relative path and a parse text. Simple. After that, for this parse text, we will chunk this text. So I have created a table for the chunking thing. Just simply chunk byte data, and in chunk byte data, I'll put inbuilt function from the Snowflake Cortex itself and save the data into chunk byte itself. Chunk byte data. You can see insert into chunk byte data the name and the chunk. So I'm selecting the data and simply applying a Snowflake Cortex split text recursive character. Yeah, there are some more things like parse text, markdown, in which we need to like MKD format. Yeah, this is the size of a chunk and this is the overlapping. Like between the two chunks, the amount of character we need to, I can say, overlap. So after that, it will say your data is converted into 11 chunks and it will simply gives me this type of data. After that, I am simply converting this whole thing into embedding using a simple embedding model provided by the Snowflake Cortex itself. I'm simply creating a table named bike search service. A warehouse is a RAG warehouse. Yeah, a target lag. Like it will, I'm provided 1 minute. It will simply do the 1 minute refresh, I can say, so that if the data comes after 1 minute, it will update it just for the simple thing. So that's it. We have done our first step. That is, we have parsed the data. That is, if the data is in the PDF form, we will get the data, apply some chunking, and convert it into embedding and store it. That's the whole first step. After that, we give a query, or I can say, we'll first made a Cortex search function, which will simply act as a librarian. That is, get the query, get its relevant book based on that this, So in this section, see, up to this, I am using the whole SQL data, but for this, I am using Python. I'm making a class, simple cortex search retriever with some parameters in it. The limit to retrieve says that the top relevant, the top, I can say, I'll give a topic to the librarian. It will give me 4 relevant books. So it's the top relevant, how many books I can say, or I can say how many chunks you get. So I'll provided it 4, and I'm simply defined retrieve function and using a cortex search service on bike search service. That is our chunk. Okay, not the chunk, on the whole data. Sorry. Yeah. So it will basically as a query, the question which will the user ask, and the column is chunk, and the limit is 4. So it will simply return me a answer. I'll also show you if. So I have also tested, like, if I call this, is this any special lubricant to be used in the premium bikes, as my data is of the bike itself. I can start a session by this. So let's say we get our data, we get the top relevant data. After that, what we need, we'll give that data to kid or our LLM along with the query. It will read it, it will simply explain it and give me the relevant answer. So I have simply provided a prompt that you are an expert and all. After that, I'll simply using the Mistral large function to generate the response, and I'll simply asking the question, and it will give me an answer. Yes, there is a specific lubricant recommended for use of this premium bike and all. Is it as simple as it? As we have seen, I think we will see the top relevant data. If these are the top relevant data based on my questions, I have passed here 3, so it will gives me a 3 relevant context. So congrats, you have first year AI chatbot, I can say, based on a specific specific tailored data you have your own. So in this session, we have seen how we can make this whole thing done using Snowflake Cortex. So that's from my side. Thank you.